Today's topic is radical equations. Radical equations. Yes, that is radical indeed. All right, something we haven't done in quite a while. We have not had a video watching quiz. I know that some of you have been going straight to the end of the videos, trying to get the assignment without bothering to watch the video. I can imagine a number of reasons why a person might want to do that, none of which are very good. To encourage you to actually watch the videos, I need to get back to putting some quizzes into the videos. I know it's not a foolproof system, but hey, it's better than nothing. Quiz question number 1. What is today's topic? You might need to rewind a little ways to see the previous screen to see what today's topic was, if you have already forgotten what I said 60 seconds ago. But today's topic, what is it? That's quiz question number 1. Please remember the format for this. In your subject line, put Algebra 2A or 2B, and then the word quiz 7-6. This is section 7-6. That's all I want to see in your subject line. That makes it very easy for me to sort out the emails. And then in the body of the email, don't put this on paper and then take a picture. Too much trouble for me, too much trouble for you. Just put right in the body of the email, type in the 4 answers to the 4 quiz questions. First one, what's today's topic? All right, let's dive in. The strategy. This is a radical equation because obviously, first it's an equation, so it's a radical equation, but it has a radical in it. We haven't seen one of these before. So what do? What's our strategy? Here's your strategy. Get the radical by itself. That is your primary strategy. It's not by itself yet. We got that -3 sitting there, so let's go ahead and add 3 to both sides. If we add 3 to both sides, we get, bang, gone. Over here we have 7, no problem. Now, what we didn't look at yet was Theorem 7.7. Theorem 7.7 says that just like I can add the same thing to both sides of an equation, I can multiply both sides by the same thing, I can also square both sides. Or if I wanted to, I could take both sides to the 3rd power or the 4th power. Here, I'm going to square both sides. Why? Because a square out here will cancel the square root. So I square this side and I square this side. What do I end up with? Well, what's the square root of x squared? It is x. Let's make that white, make it stand out better. X is 7 squared, 49. Ta-da! That was easy. Big question though is, does that 49 actually work? Take the 49, stick it back in here to the original equation. What is the square root of 49? It is 7. 7 minus 3 is 4. Yes, it does work. It works. Ta-da! Congratulations. No problem. All right. Quiz question number 2. Did it work? Okay. Obvious answer, right? Okay. All right, this one. Let's see if this one works. We need to first get the radical by itself. Let's get rid of that +6. Let's subtract 6 both sides. Subtracting 6 on this side, +6, poof, gone. Subtract 6 on this side. What's 3 minus 6? Please watch your arithmetic. Be careful. 3 minus 6, -3. We're not doing 6 minus 3. We're doing 3 minus 6. -3. Now, same thing we did before. Let's square both sides. Square this side, square that side. Yes, that's legal. On this side, squaring the square root, poof, cancels. I get x. Look at this. We've got x by itself. Congratulations, we're practically done. What is -3 squared? -3 squared, of course, is 9. Ta-da! Okay, question. Does it work? Well, let's find out. We take our result of 9, and we will plug it in here where x used to be. Square root of 9 is 3. 3 plus 6 is 3 plus, what did we do wrong? Put a 9 in here. Square root of 9, principal square root, positive square root of 9 is 3. 3 plus 6 is not 3. Something went wrong. We got a wrong answer. We did not break any rules, but we got a result that does not work. Because this one does not work, no good, we call it an extraneous root. A root is the fancy word we give to answers to these things. And extraneous implies it's an extra answer. It's an answer that is not real. It doesn't work. It's not true. It's also sometimes called an erroneous answer. Erroneous referring to an error. No, it's not an error you made. You followed all the rules, but you got an answer that doesn't work. It's an extraneous root. An extraneous root. So how do we answer this then? Well, we write off on the side someplace that there is no solution. That's your answer, because this does not work. We could have gotten a hint of that some time ago, way back here before we squared both sides. Can a square root of any number ever be negative? No. Square roots cannot be negative. So right back here we could have seen, oh, it's not going to work. You can't find any number that will go in here that will give you a negative answer, because principal square roots are always positive, never negative. So there's a problem right off the bat. Is it always that easy to spot? No, not always. All right, so this one does not work. Quiz question number 3. Did it work? The previous problem on the previous screen. Did it work? 2-letter answer. All right, this guy. Now this one is, this one's going to be a little bit trickier. Your first task, your first process is get that silly radical by itself. To kill off the radical, you have to get it by itself. So we've got to get rid of that plus 5. Let's subtract 5 from both sides. Uh-oh, gets kind of ugly, because on this side, if I subtract 5 from this side, I get x minus 5. Let's do this in color-coded form. I'm going to subtract 5, and on the other side, if I subtract 5, of course the 5 is just gone. Subtract 5, poof, gone. Subtract 5, there it is. Okay, I've got the radical by itself. So what do I do now? Same thing we did in the previous problem. We square both sides. But that's where it gets fun. We're going to square this side. Let's use parentheses to make it crystal clear what we're doing. I also square this side. Yes, I have to square the entire x minus 5. Well, that's a pain. Yes, it's a little bit of a pain, but you know the trick for squaring a binomial. No big deal. The trick for squaring a binomial, you could do x minus 5 times x minus 5 and use FOIL. But why bother with FOIL when there's a better shortcut? To square a binomial, we square this guy. We multiply these two and double the answer. And we square this guy. So squaring this binomial, we have x squared minus not just 5x, but minus 10x. Watch out that we match the sign here. And then plus 5 squared, 25. That's now equal to, and the square and the square root cancel. It's equal to x plus 7. So what in the world do we do now? Well, this should look kind of familiar from a past chapter. We just get everything, because we have a square involved here, we're just going to shove everything to the left side. Shove it all to the left. Let's subtract x from both sides. Minus 10x minus 1 more x is minus 11x. And then 25 minus 7 being 18 is now equal to 0. Now that we've shoved all this stuff to the other side, do you recall what to do with this? It's been a while, but I think you should remember. We factor. Oh, we haven't seen factoring in a long time. Yeah, it's about time we saw it again, isn't it? It's kind of fun stuff, right? To get the x squared, it's got to be x times x. To get a positive, remember, the last term here comes from multiplying the last times the last. FOIL, lasts, okay? To get a positive, either they're both going to be pluses or they're both going to be minuses. Well, this guy being negative says they must both be minuses. So we're going to subtract a couple things. We need two numbers now that multiply to give 18, but add to give 11. Oh, there's no such thing. Think about it again. Oh, yes. 2 and 9. That wasn't hard. No, it's not hard. Because negative 2 times negative 9 is positive 18. And negative 2 minus 9 is negative 11. It works. So what are my solutions then? Just a quick review of an old chapter here. If I've got two things that multiply to give 0, the only way these two things can multiply to give 0 is if either one of them or the other one, or both, are zeros. Well, what would it take to put in, what x would you put in here to make this turn into a 0? If x were 2! That's right, if you put a 2 here. So one of your solutions would be x is 2. And here, what could you put here to get a 0? A 9. So x is 9. But we might have extraneous roots. What is it that causes extraneous roots? Extraneous roots can happen anytime you square both sides of an equation. If you square both sides of an equation, then you need to go back and check and see if your answers actually work. We got answers of 2 and 9. We get answers of 2 and 9. Let's check them both. In the original equation. Right here. All right, let's put in a 2. Does 2 equal the square root of 2 plus 7 plus 5? Putting in a 2 here and a 2 there. This is square root of 9. Square root of 9 is 3. Whoa, wait a moment. Hold on a second. Is there something wrong here again? I'm putting a 2 in here and putting a 2 in there. I put my 2 in there. I put my 2 in there. Square root of 2 plus 7, that's square root of 9. That's 3. But 3 plus 5, no way it's going to be 2. That guy didn't work. Well, let's try the 9. Trying the 9, get rid of that, fix the damage here. Okay, all right, let's put a 9 in there. I put a 9 here and put a 9 here. Let's see how that one does. Square root of 9 plus 7, square root of 16, that's 4. 4 plus 5 is 9, 9 equals 9. That one did work. So in this case, we checked both of them. We found out one of them did not work. The other one does, so your only solution is, let's do it right here, x equals 9. That's the only solution. The other one is an extraneous root. Only 9 works. All right, it is your job on homework and especially on the test when that comes along. It is your job to check for extraneous roots. If you give me an answer that actually is not an answer, such as 2, you lose points. All right. Oh, another quiz question, the fourth one. Quiz question number 4. What do you call a solution or a root that doesn't work? Yes, I had the word printed on the previous screen. You can go back to that, and I said it out loud a number of times. You can go back and find it out. Hopefully you just plain remember. What do we call a solution that doesn't work? And by the way, does that mean that you did something wrong? No, it doesn't mean you did something wrong. It's simply the proper procedures produced a solution that didn't work. It happens. All right. Let's see. This one is a bit different. I've said already that your strategy is to get the radical by itself. Well, to get this radical by itself, I would subtract 1. Then I would have a minus 1 over here, which would look like this. Square root of 2x minus 5 minus 1 equals square root of x minus 3. Okay, we got the radical by itself. Oh, but this one's not by itself. Okay, let's get this radical by itself. So we'll add 1. If I add 1 to both sides, what do I get? I get this. But the radical's not by itself anymore. We can't get the radical by itself. That's right. So we need a new strategy here, because we can't get the radical by itself. So what do? Warning. Do not let these two radicals get together on the same side. When you have one radical on the side and one on that side, it's okay. We can handle that. But if you were to allow, subtract this guy, equals, we're left with 1. If you were to allow these two radicals to get together on one side, they team up together and they have new strength and they will destroy you. They are extremely dangerous if you let them get on the same side of the equation. Do not let these guys get together like that. The longer I leave them on the board, the more powerful they're getting. No, you do not allow the two radicals to get on the same side of the equation like this. Very, very dangerous. We leave them on opposite sides. If you're given an equation where you've got two radicals like that on the same side, with a plus or a minus in between, you need to get them separated fast, or they will kill you. Keep them on opposite sides of the equation. Now they're weak. We are safe. So what in the world do we do then? We dive right in and square both sides. We'll square this side. That's easy, right? The square and the square root cancel each other. On this side, here's the problem. We have to square the entire right side of the equation. We can't square just a piece of it. We've got to square the whole thing. Oh, Mr. Pierre, isn't that going to be a little ugly? Oh, yes, you're right. It's going to be a little ugly. But we can deal with ugly because we're good. All right, let's go ahead. On this side, the square and the square root, poof, gone. We're left with just 2x minus 5. Ta-da! On this side, this is kind of like a binomial. We've got to square a thing that's kind of like a binomial. So we're going to have to use the same shortcut we used a little bit ago. A squared plus 2ab plus b squared. So, a squared, what's 1 squared? 1. So far not too tough, huh? Plus 2 times a times b. 2 times 1 times square root of x minus 3. That would be 2 times the square root of x minus 3. 2 times that plus, 2 times that times that. Then we add what? This guy squared, just like always. We square this guy. What's square root of x minus 3 squared? It's x minus 3. You say, but wait a minute. We still have a radical. Yep. But before, when we first started, we had 2 radicals. That was a problem. Now, because we very cleverly squared both sides, now we have only 1 radical. Now we go back to our old strategy. Get the radical by itself. Now we can. Now we can. Getting the radical by itself. Let's see, a number of things we do first. Let's do some of this in our head because you guys are good with basic equations. At least you better be. Let's subtract 1 from both sides. That'll become a minus 6. Subtracting 1 more. That's a minus 6 now. And then we'll add 3. So the minus 6 plus 3 will be a minus 3. That minus 5 is gone. The 1's gone. The minus 3 is gone now. If you don't like my shortcut, then go ahead and write the whole thing out for yourself. Then let's get the x's together. Let's subtract that x from both sides. So it's now gone. That 2x becomes a 1x. So I got rid of my minus 3, I got rid of the 1, I got rid of the x. The only thing left now is the 2 times the square root of x minus 3. By the way, when I say get the radical by itself, it is not necessary to get rid of multiplications. I mean, if you want to, you can divide both sides by 2. That gets a little bit ugly over here. Feel free to leave that there. Multiplications, we can leave there. We don't have to get rid of it. So when we say get the radical by itself, it's okay to leave multiplications there. It's just additions and subtractions that we need to get rid of. Now guess what? Yeah, you guessed. Square both sides. This problem is really nasty. Yeah, it's kind of long and involved. It's not hard, it's just tedious. Remember, tedious is not the same thing as hard. If you think tedious is hard, that has a special name of its own. That's called lazy. This is not hard, it's just tedious. Tedium is a part of life. We square both sides. On this side, we get x squared minus what? Minus 3 times x doubled is minus 6x. And then square the minus 3, we get plus 9. On this side, we've got to be very careful. Yes, we know that the square and the square root cancel each other out, but don't forget you also have to square the 2. It's 2 squared is 4 times the square root of x minus 3 squared, which is x minus 3. Those parentheses are vitally important because we're multiplying 2, actually we're multiplying 4 by the whole thing squared, not just a piece of it, but the whole thing. Those parentheses matter. So from there, it's a pretty ordinary equation. We've seen these kind before. Multiply this out. That's 4x minus 12. That's why those parentheses are important. Without the parentheses, you wouldn't have multiplied 4 times 3, and you wouldn't have 12, and you would be all messed up. Here, x squared minus 6x plus 9. And then from there, we will do what? Let's add 12 to both sides. Because we have an x squared involved here, we need to get everything to the left side, get a 0 on the right side, and factor. So, yes, what we're doing, add 12 to both sides. Adding 12 here. Let's use the eraser method, which I do not want to see on your papers. I want to see the steps shown. But that's too many steps. Get over it. You'll be okay. Yeah, it's a bunch of steps, but that's all right. That makes it look more impressive. So we add 12 to this side, it's gone. We add 12 to this side, we get 21. Then we'll subtract 4x from this side, it's gone. And subtract 4x from this side, we get minus 10x. Now we just need two things that multiply to give 21 and add to give negative 10. Shouldn't take too long to come up with x minus 3 and x minus 7. Because negative 3 times negative 7 is positive 21. And negative 3 plus negative 7 is indeed negative 10. It works. So our solutions are x is 3 or x is 7. By the way, why did I use the word or here? Because we have a choice? Not really. I use the word or because x can't be both 3 and 7 at the same time. It can be a 3 or it can be a 7, but it can't be both a 3 and a 7 at the same time, so we use the word or. Is that a critical detail? No. If you don't use the word or, would I ever count that wrong? No. In fact, you can just do it like this. I'm quite happy as a comma. Make it look like a comma. However you want to express it. Your answers are 3 and 7. But we need to check them. See if they both work. We go back here. We put a 3 in here. That gives us 6 minus 5 is 1. Square root of 1 is 1. Over here we're going to get 1. We put a 3 in here. 3 minus 3 is 0. Square root of 0 is 0. Plus 1 is 1. 1, 1. It works. Tell you what, saving some time here so you won't be too terribly bored. If we put a 7 in, guess what? 7 also works. You can try it for yourself. They both work. This time we actually do get 2 answers. They are 3 and 7. And that's it. So your basic strategy is get the radical by itself. And then square both sides. If you can't get the radical by itself because there's a radical on both sides, keep them on opposite sides. Don't let them get together. They'll gang up on you. Keep them on opposite sides of the equation. And then carefully square both sides and expect a lot of extra steps. Because the first time you square it, one of your radicals goes away, but the other one survives. Then you get that one by itself and square both sides again. Yes, you have to square both sides twice on one of these guys. And then you get one of these old familiar friends, factor it, and we are done. Ta-da! A plus coming on the next test. All right, that's all there is to it. Oh, I think there was one more thing I wanted to point out. Yes, how do you start with this one? Little bit different than the other ones we saw. This is a case where we've got 2 radicals joined with a plus sign on the same side of the equation. These guys are just waiting to strangle you. They will kill you if they get a chance. Don't let them survive that way for long. Get rid of that plus square root of x. Subtract square root of x from both sides. Now we've got the radicals on opposite sides of the equal sign. Now they're safe. Now they can't hurt us. Now we square both sides just like we did in the previous example, and everything falls together rather nicely. It's not going to get any worse than that on the assignment. Okay, speaking of assignments, there we go. Page 319, numbers 2 through 30, even. Page 319, 2 through 30, even. All right, that's it. See you later.